Hello, hello, hello. I just had a quick video that I wanted to make on a consequence of Euler's-Toshin theorem, typically called reducing the modulus. And so this is useful for a lot of competition math problems, modulus. And the way it goes is, we know by Euler's-Toshin theorem that a to the phi of n is congruent to 1 mod n. For the GCD of a and n being equal to 1. In other words, relatively prime. They share no common factors. And remember that phi of n is the number of numbers from 1 to n relatively prime to n. And now the theorem here is that if we have x being congruent to y mod phi of n, then that implies that ax is congruent to ay mod n for the GCD of a and n equal to 1. And it goes like this. If x is congruent to y mod phi of n, then x minus y is congruent to 0 mod phi of n. In other words, x minus y is a multiple of phi of n. And so let's write that down. X minus y is some constant times phi of n. It's a multiple of phi of n. But that means x is equal to k phi of n plus y. And so now that means that a to the x is equal to a to the k phi of n plus y, which is equal to a to the phi of n to the k times a to the y, which is congruent to 1 to the k times a to the y mod n by Euler's-Toshin theorem, which is congruent to a to the y mod n. And we're done.